This is Chapter 10, Video 7, goes with Section 10.7, and we're going to be comparing populations now. So if you didn't already watch it, you need to watch Video 0 that goes over some of the stats review that we're going to be using in this section as well. Okay, so the target, we're going to look at data from two different populations and be able to compare them. So looking at their visual representations and then kind of finding out some information about those different populations and then comparing them. So we need to know what are the measures of center. So measures of center, think of this kind of as like a vocab word. Measures of center are the mean, median, and the mode, okay? And those things tell us about the middle or the average of your data set, right? Mean, median, and mode kind of tell you what's the middle or the average of these numbers, okay? That's different, a little bit different from measures of variability, okay? The measures of variability are the range, the IQR, and the MAD, the mean absolute deviation, okay? Again, these are things, all of this so far, are things that we talked about in Video 0, so if you need to go back and watch that, please do. So the measures of variability tell us how spread out the data is. So it doesn't have anything to do with where's the middle or where's the average of the data, it tells us how spread out is the data. Okay, so I want to look up here at this picture. Here I have kind of numbers from two data sets. Just picture if these are a bunch of numbers, right, in these two data sets. I'm going to color code them here. The mean or the average, right, or the middle of this data set would be right there at, looks like 30. Compared to the mean or the middle or the average of this data set would be 50. Okay, so we can talk about where's the middle and compare those for these two populations. But we can also talk about how spread out the data is. Notice that this data is all closer together. It makes a tighter, higher peak. So this data is closer together. If I thought about this MAD, this mean absolute deviation, it'd be pretty small. Everything is pretty close centered around this mean or middle number. Compared to this data set that's lower and more spread out, right? I have more data points out here on the edges maybe. So you can see this, the green data set, would have a larger MAD, a larger mean absolute deviation. The data is more spread out, okay? Same thing here for this dot plot, right? We can see, all right, I think there are 12 of these data points for Elena, 12 of these data points for Jada. You can see that Elena's numbers, her data points, are more spread out, right? They're further away from whatever this middle value is. Compared to Jada, who's a little bit closer, a little bit tighter, right? Her data is not quite as spread out and closer to her mean or her average there. Okay, so these are just examples of kind of comparing different populations by looking at the visual representations of the data. Okay. Here's one more example. I have 3 data sets here. You can see that they all have the same mean or average or middle, right? But for each of these different data sets, they have different amount that they're spread out. Okay. So let's look at this example, box and whisker plots. I have test scores from first hour and second hour. Okay. Let's find the range for those and compare them. All right, well, the range for first hour looks like it goes from 90, I'm going to call that 98, we'll say, 98 down to 60. So if I find the range, that's a range of 38. And the range for second hour from 70 to 95, right? Biggest minus the smallest, so 25. Okay, so now if it says compare the ranges, often what they're looking for here is for us to say how many times bigger this range is, right? So if you can see on my calculator, I have typed in 38 divided by 25. I took this range, I'm going to write it down, 38 divided by 25, and I got on my calculator this decimal, okay? So the range in first period, first hour range is 1.52 times bigger than second hour. Okay, so I found both ranges and divided them Oh, and this one is 1.52 times bigger than that range. Okay, let's do the same thing with IQR. Okay, well, the IQR here, remember IQR is the box, right? Q3 minus Q1. So how big is this box? From 90 to 75. So for first hour, the box, the IQR is 15 for first hour. Second hour, the box is, I'm going to call this 92 and 80, right? So if I look at that box is only 12. Okay, well, compare the IQRs. We're still going to take the bigger one on top and divide them. 15 divided by 12 on my calculator is 1.25. So this IQR is 1.25 times larger than second hour. Okay, let's do the same thing with the median. Well, I can look at the median here. I see that this median for first hour is at 80, and this median for second hour is at 85. Okay, and if they ask me to compare them, you could say, this one it probably just makes more sense to say this median is 5 higher than that median. So the second hour median is 5 greater or 5 higher than first hour. Okay? So just thinking, able to find the range and the IQR and the median and kind of compare them in a sentence. Okay, another example. So here's another example. I don't have a picture, I don't have a graph or a chart or anything, but I'm just given the mean for population A and the mean for population B. Okay, so let's look at those means first. Mean for A and mean for B. It says compare the means. Okay, well, I can see that the means are 6 apart, okay, but I also want to be able to kind of compare if I say how many times larger is this mean. So we're going to divide the bigger one divided by the smaller one. 16 divided by 10 is 1.6. So I can say the mean of population B, so the mean of group B or population B is 1.6 times larger than group A. Okay. All right, how about the MADs? They did the work here and found the MADs for me. So now I'm comparing the MAD for A is 3 and the MAD for B is 6. Okay, well, again, I'm going to take the bigger one divided by the smaller one. 6 divided by 3 is 2. So the MAD for, and this time B is, B was larger before as well. The MAD for B is 2 times larger than A. Okay, so I'm just taking the numbers and I divide to figure out how many times bigger it is. Okay, this next question seems a bit silly, but it's something that we need to be able to find, and we're going to see it on quizzes and on our test. So this question says, express the difference in the measure of center as a multiple of the measure of variation. Okay, so I'm going to go through what this is asking. Express the difference in the measure of center. Okay, well, I know difference means to subtract. Okay, measure of center, they give me the mean as the measure of center. So this first part just says subtract the means. Okay, if I subtract the means, they're 6 apart, right? The difference between 10 and 16 is 6. Cool, so I got that part. And I want to express that as a multiple of the measure of variation. Well, the measure of variation in this example is the MAD. Okay, so because I have 2 different MADs, I have to do this twice. All right, so we got that the difference in the means was 6 compared to 3. Well, 6 compared to 3 is 2 times larger. Okay, and then I'm going to do it again for this MAD. 6 compared to 6 is 1. So this is the same as the MAD. Okay? I know it seems like why we're doing this doesn't make a lot of sense, but it's a calculation where we're able to kind of understand what this is asking and use the numbers they give us. Okay? Let's do another example. Okay, I'm on the back page, kind of in the middle. Find this example, restaurant A and restaurant B. All right, first they asked me to find the mean. So I have to actually do the work here and find the mean for restaurant A and find the mean for restaurant B. So I want you to pause. Then we know we're going to be adding these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like I have 10 numbers. So I'm going to get the total here and divide by 10. Get the total here and divide by 10. Find the mean for both of those restaurants. Okay, you can check me, but for the sake of time, I added these numbers all up and got 173 divided by 10 numbers, gave me an average here of 17.3. I added all these numbers up, 158 divided by 10 numbers, and I got an average of 15.8. Okay, so we can see that the average for restaurant A is a little bit higher, right here, 17.3-ish, and the average or the mean for the second restaurant is here-ish. Okay, so a little bit lower. Okay, then they asked for the MAD for both sets of data. Well, I know I have to use this mean, and I want to know how far away are each of these numbers from that mean or from that average. So I'm going to pause it again, and I'm going to calculate how far is this away, this, right, and get that list, and then find the average of all those. So review video 0 if you need to, but we should be able to calculate the MAD, and you're going to need to calculate the MAD. So pause, and we'll both work this out now, and then check when you're ready. For the sake of everybody's sanity, we're going to use 17. We're just going to round these. I want you to use 17 as the mean and 16 as the mean, just so we're not going crazy here. All right, so use those to calculate your MAD. Okay, so I figured out how far each of these points were away from 17, and then added all those numbers up in the list and divided by 10. So on average, all the points here are 2.3 away from my mean from 17. And I did the same thing here. How far away are all of these points from my average of 16? And these are all 2.2 on average, 2.2 away from my mean. Okay? So, again, this crazy sentence says, express the difference in the measure of center as a multiple of the measure of variation. Okay, well, the difference in the measure of center means subtract these two numbers. So the difference in the measure of center is 1, right? The difference between my means. As a multiple of the measure of variation. Okay, well, the measure of variation here was 2.3. And if I do it for this one, 2.2. Okay, so when I divided that, right, I just typed this into my calculator and got a decimal. So here, the difference in the measure of center is 0.43 compared to that measure of variation, the MAD I got for A. And here, when I divided, it's 0.45 compared to the MAD, right? 0.45 times as big as the MAD for restaurant B, okay? So, I know this feels confusing. I wanted to have some examples there for you. I'm going to zoom out here. We did not get to this example at the top yet, but it's just like one on the front. And we did not get to cover this example yet, but it's just like the one we just did. So that's your video, and we're going to keep talking about it in class.